Hello folks, I decided to make a short video about comparison between symmetric and asymmetric airfoil and how some data is changing and how basically the asymmetry in wing airfoil affects the lift capabilities. So as you remember, in the previous video we did some analysis in XFLR5. We compared NACA 0009, as you wish, and NACA 4412. So basically that's the symmetric airfoil, that's asymmetric airfoil. And I want you to pay attention now to these graphs. Here you see some polars of airfoil, and let's talk about lift coefficient polar, which is this graph. So basically dependencies of the lift coefficient to angle of attack, alpha. If you press 2 on your keyboard, this graph will become bigger and you're going to see it separately. With a yellow color, it's given polar of symmetric airfoil, and with a blue, it's given for the asymmetric airfoil, 4412. The first thing what you should pay attention to is basically to identify if the airfoil is symmetric or not. The easiest thing to identify symmetric airfoil is at the zero angle of attack. If the coefficient of lift equals 0, it means it's a symmetric airfoil then. It doesn't produce any kind of lift, so it's symmetric. And you see the difference here. In case of asymmetric airfoil, that's approximately 0.5 is the lift coefficient. So as you can see from the graph, both airfoils continue to increase their lift coefficient while increasing angle of attack. And at some point, the lift coefficient starts decreasing after some specific angle. For the symmetric airfoil, it's somewhere 9 degrees. And for the asymmetric airfoil, it's somewhere at 10. I don't really see the results of the 10 degrees because the simulations have not been made after 10 degrees of angle of attack. But that's the idea. Basically, you reach some kind of peak and then it drops because you go in stall. So there's some separation of airflow from the top surface of the wing and instantly decreases coefficient of lift. What you should take into account is basically for each airfoil, where do you have the maximum coefficient of lift? That's going to be the critical angle of attack for you, because after that it starts decreasing, so you go into stall after that point. And also for the asymmetric airfoil, what specific value of lift coefficient you produce at 0 angle of attack. And meanwhile, when your lift coefficient equals 0, what angle of attack you have. So basically, what's your 0 lift angle? That you should consider during wing design for the asymmetric airfoil. Except this graph, quite important graph as well. Obviously there's lift coefficient to the coefficient of drag and drag coefficient to angle of attack, etc. Those are important. Moment coefficient. Okay, we can review maybe all of them. The first one is the lift coefficient over drag. You should press 1 on your keyboard, and that's how this graph separately opens in your window. You see basically dependence of the lift and drag coefficients. That's again lift coefficient to angle of attack. That's the coefficient of moment to angle of attack. That's also important if you want to design stable aircraft. We will cover this in detail during the wing design, but you should have in mind that except symmetric airfoil, every airfoil at 0 angle of attack produces some kind of pitching moment, therefore it has some kind of moment coefficient. For the symmetric airfoil, at 0 angle of attack it equals 0. But here is the most important part now. It's gliding ratio, CL over CD, to alpha. So basically lift to drag coefficient ratio to the angle of attack and how it changes. And you see for the symmetric airfoil, it's 0 at angle of attack 0 again, and while you increase it, it goes to some kind of peak somewhere around 3.5, 3.6 degrees, and then slowly decreases. So this area is the most effective for using symmetric airfoil. And for the asymmetric airfoil, the second one we have, as you see, the maximum value is somewhere around from 7 till 8, somewhere like 7.5, around that. After which it starts decreasing. It means basically that the drag is increasing more than lift coefficient. So you should have always in mind these parameters to look which are the critical parts on these graphs. And the last one is drag coefficient to angle of attack, which is also super crucial because it shows on a specific angle of attack what kind of drag coefficient you have. But actually, to find the optimal dependencies, you will use mostly this graph. So to have in mind lift coefficient to angle of attack and the gliding ratio to angle of attack, these two are the most important during wing design stage, to which we will move in the next videos.